Okay, so we're going to talk about quadratics. When I say quadratics, well, technically speaking, the definition of a quadratics would be a univariate, meaning there's one variable on one side of the equation, and that variable is taken to the second power. But what I'm going to say when we're talking about quadratics is pretty much x or y is taken to the second power, because the same problem-solving techniques and processes are going to be employed, and I want them in the same, folder. When we talk about folders in our brain, I want you to think about the same things when we deal with any equation that's taken to the second power. Okay? And when we say quadratic, we really mean, or you can think of it to mean having to do with the quadrilateral. Okay, so square, you take something to the second power, we call that a square, right? A square is the regular quadrilateral. Okay, all right. Quadrilaterals. Okay, the standard form of the quadratic is this: ax squared plus bx plus c is equal to 0, or we could say y, or f of x. These have slightly different uses. Typically speaking, we're going to say ax squared plus bx plus c equals 0. That would be the univariate. But you're going to see y and an f of x, especially if it's going to be graphed. Okay? There are two other forms of the quadratic that you're going to need to know. That is going to be the quadratic formula, which we will cover, and the vertex form of the parabola, which we'll also cover. Okay? If you're taking the ACT, you don't need to focus on quadratics quite as much as you need to focus on geometry and trigonometry. So when we do the geometry and trigonometry section, I'm going to say if you're taking the SAT, you don't need to focus on this quite as much. So you kind of have different focuses, and that's the main difference between the ACT and the SAT, at least math-wise, is that the ACT has a lot more geometry and trigonometry, and the SAT has a lot more algebra. Okay, but if you want to have a somewhat decent score, or a score that starts with a 3 on the ACT, you're going to need to pay attention to everything I say here. And even though there's not as many quadratic problems on the ACT, whatever they do have is usually pretty hard. Okay, so this is still for you if you want a really good ACT score. All right, quadratics. We're going to start out by kind of just understanding the nature of the quadratic. Let's do y is equal to x squared, okay? We would call this a monomial because we only have one term here. When we have y equals x squared, we have a shape. You know what I'm going to do? I'm actually not going to try drawing it. It's just going to look weird. We have the shape that looks like this. Let's see if I can zoom out a little. Let's see. Okay. Let's get to 4. Yeah. Now, what you want to realize is that it's symmetrical. This is very important. The parabola is symmetrical, and the reason this is symmetrical is because when y equals 1, we have two potential inputs for x. X could be 1 or -1. When y is 4, x could be -2 or +2, and so on and so forth. Okay? There's a lot of interesting things about the parabola which we really don't need to go into because they're not covered on either test. But if you know what the vertex is, you didn't know about the vertex, but if you know what the foci is or the directrix, great, but that's not going to help you on this test. They don't really talk. I don't think I've ever seen them mentioned on either test. Okay, if I want to move this parabola up, I'm going to do this. Oops, I'm not. I'm going to do that. Cool. If I want to move this parabola to the right, now, am I going to do x plus 1 or I'm going to do x minus 1? What am I going to do? I'm going to do x minus 1. And you want to kind of think about why that is. Well, even though we've got minus 1 here, for this to equal 0, which is where this hits, that's y is equal to 0. Well, then this has to equal 1. So even though we have x minus 1, so you're thinking, well, there's a negative 1 there, it's really x has to then therefore be 1, you know, because it's going to be 1 minus 1. I hope that makes sense. Okay? Okay, and if I want to make this, this is a little bit hard to explain. If I want to make this flatter, or maybe you could say fatter, I know that doesn't really make sense because parabolas technically will go up through infinity, but you could say like flatter or fatter over a given interval, then we're going to have a coefficient. So that coefficient we're going to call A. And if it's positive, which means the parabola goes up, then A is going to be between 0 and 1. Let's call this 2, actually. No, let's call this 1/2. I'm going to call it 1/2, but typically speaking, you know, it would probably be x squared over 2 is probably what we would, that's how you would see it. But we're just going to make this simple and do that. So you'll notice that it's wider at the same interval. Okay, and then if we wanted to make it thinner or taller, again, in a given interval, then at A is going to be greater than 1. Okay. Now, if I wanted this parabola to go down, I'm just going to have this be negative. Okay. The same rules apply for the A, except it's just going to be negative. Okay. That's not really what I want to do. Okay. When we put this all together, we're going to end up with this form, you could say. Y is equal to A x minus h squared plus okay? Now, H and K will be what we would call the vertex. So we call this the vertex form. It's very similar to how in linear algebra you can tell very quickly the shape or kind of what you can eyeball in your mind by looking at the slope-intercept form of the line. If you understand the vertex form of the parabola, I have to apologize, it's kind of hard to write with a mouse. If you look at the vertex form of the parabola, you should be able to tell what something looks like. If A is positive or negative, you know, if A is positive, it's going to go up. If A is negative, it's going to go down. If the absolute value of A is going to be between less than 1, then it's going to be fatter. If the absolute value of A is greater than 1, that's going to be thinner. H and K is then the middle of the vertex of the parabola. Okay? Great. You're going to have quite a few parabola problems on the SAT and a couple on the ACT. So make sure you understand kind of how parabolas work. They may even show up in the physics sections. A lot of things that are shaped like parabolas are like the trajectory of something thrown will be a parabola. And that shows up a lot of times in the physics problems. You don't actually have to know physics to do the physics problems, but you have to have problem solving skills. Okay? All right.